Hello and welcome to this new video in the R Analytics course. In the last video, we had seen the basics of if condition in R. We used the if condition for single value variables and for vectors both. In this video, we will use the if condition on a data set to analyze the same. Let us import two data sets first, MRP and salary data. We can see the paths for both these files over here. We write MRP data equal to read.xlsx and then mention the path of the file. After that, we mention sheet index equal to 1. As we press enter, we can see that this variable has been created with 83 observations and 7 variables in it. Similarly, we create another variable SL data and put it equal to the path of the salary data file. We have both these datasets created in R and we can check on them by clicking on this icon on the right hand side. In SL data, we have three variables: employee name, employee ID, and salary. We want to add a new column to this table by the name designation. We have to summarize the employee data based on their designation. But we do not have their designations in the dataset. How do we do this then? To work out the designation, we have been given the following criteria. If salary is less than 20,000, then the employee is an executive. If it is between 20,000 and 30,000, then the post is of an assistant manager. People with salary between 30,000 and 50,000 are managers. And lastly, if the salary is greater than 50,000, then the designation will be senior manager. The first thing we have to do is to insert a column by the name designation in the SL data table. We will use the if conditions to do this and find the respective designations of employees. To create a column, we write SL data followed by the $sign and then designation. Please remember that one is sure of the upper or lower case used in the naming of the variable. We then put it equal to if else. In the SL data table, if the value in salary variable is less than 20,000, then the value for SL designation in that record should be executive. But if the value is more than 20,000, then we will have to use the if else condition again to see if the value is greater or lesser than 30,000. So we write if else SL data $salary is less than 30,000, then write assistant manager. Similarly, if the value is greater than 30,000, then again we put the if else condition to check for the value being less than 50,000. And if that's the case, then the designation must be manager. Finally, if the value is greater than 50,000, then the designation will be senior manager. Please ensure that you close all the brackets that were open to write the code. Also ensure that one puts the quotes for all text values properly. As we press enter, we can see that a new column with the name designation has been added and it gives us the correct values as per the salary. The first one has a salary of 63,000 and hence the designation is senior manager as expected. We can go down and check for all the other records too. Now that the column is inserted, we will summarize the data. We basically want the count for the designation variable over here. For that, we will need to do the following steps. Write the name of the table, which is SL data. Then we will select the column designation. We then use the group by function for the variable. And finally, we will summarize the variable. For that, we define a new variable employee count and put it equal to n, followed by open and close brackets. N is used for counting. By using this method of breaking the problem into single steps, it makes the life of an analyst very easy. This is the main USP of the dplyr package. Nesting different functions within one another is very difficult, especially when we use R initially. That is why using the chain system is the best method. To separate each statement from one another, we will use the percentage greater than percentage symbol as mentioned in an earlier video. So we pick up command by command and separate them by the symbol like we did in the pipe operator. The moment we press enter, we get the perfect output. We then store this table in a variable named final. We can see that this table has all the 4 designations and their respective counts. Let us take one more example. We have the MRP dataset in front of us. We have 7 columns in this table as mentioned earlier. The case we have in front of us is the following. A company wants to launch a new product and wants to find out the price range in which it makes the most sales so that the pricing of the new product can be done accurately. The price ranges are defined in this manner. If price is less than 1000, then the product is economy. If it is less than 3000, then we write mid-range. Less than 5000, then high range. And finally, for prices greater than 5000, the price range is premium. So the company wants to establish that which price range gives the maximum sales to the company. Thus, we will use the if condition to find the price range for all records. We create a column by the name price range. We put it equal to if else, followed by the name of the table, which is MRP data, and then MRP. If this MRP is less than 1000, then the price range should be economy. If the price is greater than 1000, then we will use the if else condition again to see if the value of MRP is less than 3000 or not. If the MRP is less than 3000, then the range is mid-range. Similarly, we will again use the if else condition to see if the price is less than 5000. If yes, then the range is high, else the price range is premium. As we press enter, we get a warning message. The output also shows us NA in the last column. Why is this happening? Such situations do arise a lot of times in the real world. We need to check the type of data in which we are putting these conditions. To see the data structure of the data, we use a function called str. We write str and then the name of the table in brackets. As we press enter, we get this output. We get the name of the variable first and then the data structure of that variable. We can see that most of the variables are stored as factors. The MRP variable is also a factor with these levels in it. To avoid these kind of situations, when we import a dataset, we can use the option strings as factors is equal to false. Now when we check the structure of the table, we can see that all the variables are now stored as characters and not factors. Now we can see that MRP is character type. Then how can we use the if condition on it? We will thus have to convert the data type of MRP from character to numeric. To do this, we write MRP data equal to transform followed by the name of the data set, which is MRP data, the variable we want to transform, which is MRP, and we want to convert it to numeric. Thus, we write MRP equal to as.numeric MRP. We again check the structure of MRP data to see that the variable MRP is now numeric type. Now when we view the MRP data table, we see that the values in MRP are aligned to the right. Prior to changing the variable to numeric type, the values were aligned to the left. Hence, this is one trick to find the data type of a variable. If the values are aligned to the left, it is character type, and if they are aligned to the right, then they are numeric type. Now we will use our if condition on this data set. As we press enter, we can see we get the perfect output in the last column. Again, we will group our data based on price range. We will break our problem into smaller comments again. First, we want the name of the table, which is MRP data. Then we will select price range and sale quantity variables. We then group the data by price range and finally summarize it by sale equal to sale quantity. To get a sorted output, we arrange the table in descending order by sale quantity. We will use the pipe operator as earlier to write the code in R. We first give the table name followed by percentage greater than percentage. Then we select the variables price range and sale quantity. Please ensure you write the names of the columns exactly the way in which it is mentioned in the table. We then group by price range, summarize by sum of sale quantity. As we press enter, we get an error since the names are not written in the correct case. As we press enter now, we get the correct result as desired. We now arrange this data in descending order. Again, we get an error upon pressing enter. The error is occurring because the new table we have created has no variable named sale quantity. The new variable created by us is sale. Thus, we have to arrange the data based on sale. Before doing that, let us save the table in a variable named final. We can click on the view icon to see how this table looks like. We will now arrange the final table. For that, we write arrange followed by final, descending, and then the name of the column sale. As we press enter, we get the arranged table in front of us. We can see that the mid-range products are sold most by the company. We save this sorted dataset in final to view the table on top. This is how the if condition is used in a dataset. One has to be careful though while using it in such datasets. This is it for this video. Thank you.